This topic is travel. It's a very important one, particularly for young drivers, I think. Now we're going to convert 40 kilometres per hour to metres per second. Now to do that, I'll write this as 40 kilometres over 1 hour. So that means per hour. Now then we'll change kilometres into metres. We want metres. So it's 40,000 metres divided by 1 hour. 60 seconds times 60 times 60 will give me the amount in seconds, and that comes out to a total of 11 1/9 metres per second. So in 1 second you'll travel 11 1/9 metres. Right, now just another comparison. Say we want to change this to 1 kilometre per hour. So look at this. 1 kilometre per hour equals 1,000 over 60 by 60 again. And that breaks down to 5/8 of a metre per second. That number there is quite useful, because rather than going through all this stuff every time, say for example we want to do 60 kilometres per hour, we go 60 times 5/8, and that will give me, I think it's 16 2/3, 2/3 metres per second. So it's quite a useful little fraction to pop in when you want to do that conversion. All right, now braking distance. Now this is quite important. This is the distance a car will travel by itself once the brakes are applied. Now this formula here, you are given that formula, you don't have to remember it, and that may change depending on the conditions. That number may change, particularly if it's a wet or whatever. Okay. So now, or the car's tyres are bald or something like that. Okay, we're going to work at the braking distance now. When the velocity is 40 kilometres per hour. This time, the velocity is in kilometres per hour and the braking distance is metres. So it's a very, very simple little thing to do. All you go is braking distance equals 0.01 times 40 squared. And that comes out to 16 metres. So if you're going only at 40 kilometres an hour, the braking distance of the car, not your reaction time, the braking distance is just 16 metres. If you did say, for example, 60 kilometres an hour, or 60 I think it is. Well, 60 kilometres an hour, the braking distance will be 0.01 times 60 squared, which I can probably work this one out, 0.01 times 60 times 60, that's going to give me 36 metres, isn't it? As the result. And that's a lot further. So you can see why they have restrictions in the school zones with that sort of thing. I think 50 is about 25, yep. Okay, then we'll move on to the next one. That'll be stopping distance. Now, in this question, we are given the braking distance formula is 0.01 v squared. Remember, v is in kilometres per hour, and the actual distance travelled is in metres. We've got to find the stopping distance of a car travelling at first 40 kilometres an hour. Now, to work out the stopping distance, call it SD, is equal to the braking distance plus the reaction time distance, or RD, reaction time distance. Now, we can work this one out to get the reaction time distance. Okay, we know that was just going to be the speed multiplied by the time. Now, but we need to put this speed in kilometres per hour. Now, remember what we did before? We had 40 times 5/8. Right, that's changing it into metres per second. And I forgot to put that in. The time was equal to 2 seconds was the reaction time. Sorry about that. Times 2. That's about the average time, about 2 seconds it takes for somebody to react to when they see the accident to pull up to about 2 seconds. So that gives me, I'll work all that out. That gave me 22.2 metres. Now the braking distance did that in the previous video. The braking distance is equal to 0.01 times the velocity squared times 40 squared, and that came out to, remember, 16 metres. So the stopping distance, SD, will be equal to this 16, right, the braking distance, plus the 22.2 metres, which gives you 38.2 metres, yep, was the actual stopping distance comprised of the car's physical business to stop and your time to react to what's going on. All right, let's try the next one, 50. Okay, so the reaction distance is going to be 50 times the 5/1/18 times 2 again, and that came out to 27.8 metres. Now to get the braking distance, that's going to be 0.01 times 50 squared. That comes out to 25. So the stopping distance, these two added together, is going to be 52.8 metres. Yep. Okay, so you can see the increase, 38.2 to 52.8 now. Travelling along at 100 kilometres an hour on a freeway, okay, and suddenly a truck stops. How far are you behind this truck? Have you got time to stop? Let's have a look. Really, how far we're behind, I don't know. So we're about 120 metres behind. Is that safe enough? Well, let's see. Okay, so the reaction time is going to be, or reaction distance is 100 times 5/18 times 2. And that comes out to 55.6, I think. 55.6 metres, still under 120. The braking distance of the vehicle is, according to this formula, 0.01 times 100 squared, and that comes out to exactly 100. So the reaction distance is equal to 100 plus 55.6. Sorry, I think you just collided with this guy. And that's quite huge when you think about 155.6, and you're going at 100. Just imagine what you're doing if you're in a Ferrari and you want to burn along at about 150, what would happen? Bye-bye Ferrari. All right, okay, that's done.